improving the knowledge and education of all our industry's participants. We couldn't have done this webinar without their support and their involvement in the industry and its education. We are registered providers with the AIA, and this course is certified. This slide, which you can see in the deck when you download it, explains how all of that works. And we're also required to have a course description. It summarizes the course so you can refer to it later. And predominantly we're going to talk about net zero. It's a presentation with a large view of what's going on with net zero, and then a couple of great case studies, and you'll hear more about that in just a moment. The learning objectives I've listed here: understanding energy potential and cost impacts, recognizing energy modeling, airflow modeling, daylight simulation, understanding what the 7 petals and 20 imperatives of the living building challenge, which is part of the Bullett Center case study, and understand the strategies employed by the design team to achieve a net zero energy, water, and waste in both of the case studies we have, and understanding complexities inherent in meeting the materials red list and radius requirements of the living building challenge. Our 3 presenters today, I'm going to start from the bottom here. I'm very excited about these guys. They're 3 people who really have a strong grounding in net zero and offer a tremendous depth of knowledge. I'll do more complete intros of each of them as we come up to the section that they're presenting. But let me start with Brian Court, who's a partner of Miller Hull Partnerships in Seattle. Greg Mella is the Vice President of SmithGroupJJR, and he's based in Washington, D.C. And Ralph DiNola is Chief Executive Officer of the New Buildings Institute, and he'll be our first presenter today. Ralph has dedicated his professional life to bringing green building innovation to scale. He's served as a technical advisor for the Living Building Challenge Standard and has consulted on more than 130 LEED projects, including 10 precedent-setting LEED Platinum certifications. As principal investigator of a landmark study of historic buildings, Ralph helped establish and validate the true value and benefits of building reuse, bridging the divide between sustainability and historic preservation. He's a LEED Fellow, founding board chair of the International Living Future Institute, founder and former principal at Green Building Services, and the 2012 Better Bricks Award winner. I'm going to turn over control of the keyboard and mouse to Ralph and let him take over his presentation. Ralph, great to have you with us today.
Thank you so much, Paul, and thank you all for joining. And we'll see if I've got mouse control now. Thanks. So I'm going to get started. I'm going to provide the context for this webinar and the focus on net zero energy and what works. And Paul, you might want to try and give me control one more time.
Okay, hold on one second. Let me keep my hands off the mouse and the keyboard, and you should have it.
Okay. Still not going.
Okay. Well, we tried this before, and for some reason it worked in practice, but not now. So if you'll just give me the heads up, I'll advance the slide.
Sure. Okay. Go ahead and advance the slide. So, I'd like to start this discussion with providing some context around what's happening in green building and sustainability, and to say that over the past 12 to 15 years of progress on green buildings, we made great progress in market transformation and development of green buildings, but we find that there's been this kind of leveling off of interest and engagement in green building standards, and so there's really a need to say what's next and what's going to really drive and inspire people, and we really firmly believe at NBI that net zero buildings are really the next wave, and standards like the Living Building Challenge. Next. And we know that we're on a path, on a roadmap to 2030, and we see this not just showing up with the 2030 challenge, but also in places like California, where they have their code trajectory towards zero net energy by 2030 throughout the state. Next. And so the goals, again, in California, the big bold goals for the state, all new commercial construction will be zero net energy by 2030. Half of the existing buildings will be retrofitted to ZNE by 2030, and all new residential to be zero net energy by 2020, which is just 5 years away. Next. And so this illustration of where we see codes going, and you know, I think nationally think of California as a leading market, and we know that if this advances in California, then practitioners are going to need to get on board with this, and we're going to see this, I think, advance across the country. We also see a trend in the Northeast of a lot of interest in zero net energy in places like Kentucky. Next. So we've been involved in trying to move the market in the state. We've been engaged by the California Public Utilities Commission over the past couple of years to host these zero net energy early adopters leadership network activities, and so we've been convening state and local government agencies, higher education, K through 12 schools, and bringing people together in these workshops that provide a venue for them to actually learn about how to get to zero and develop a peer-to-peer learning group. Next. And so these workshops have been held throughout the state, and we've gotten a lot of interest and seen a lot of activity around this, and I think it's something that we recommend to happen across the nation to really convene people around how to get to net zero. Next. And included in these workshops, we try and do a local tour. So recently in a workshop that we did on local government in San Diego, we toured the J. Craig Venter Institute, which is slated to be the first net zero energy lab building, and is on a path to that. Next. And in these tours, people get to see the buildings in the flesh and see what's working and what might not be working, and learn how these buildings are actually working in practice. Next. In our own research, we've polled the people that participate in our webinars, and we have found that there is a general consensus that the path to net zero by 2030 will be a mainstream approach, and so this is just further evidence of what we're doing. Next. So how do we get there? Next. So we have at NBI what we consider our theory of change, which is really to have this vision of what's needed in the industry, and through our thought leadership, develop primary research, develop tools and solutions, and then advance code and policy. And in this case, a focus on zero net energy has been an umbrella strategy for us, and moving the market through both deep energy retrofits, new construction practices, and education and capacity building in the industry. Next. One of the pieces of research, this was released last January, is the Getting to Zero status update, which is basically providing a assessment of net zero activities across the U.S. Next. And what we see is that this mainstreaming of net zero and prominence is showing that there's a lot of activity across the country, including Bullett Center, which we'll hear about later, and prototypes like Walgreens testing their first net zero prototype store in Evanston, Illinois. Next. So what we're seeing, and we've done this study now twice, and year over year, or in this case 2 years apart, we're seeing a real growth in the data showing how many net zero buildings are there happening in the industry. So we see 160 buildings that are either net zero verified or capable across the U.S., and that's a great growth trend. And our recent look at the database that we have has seen an even greater growth over the past year since we did this study. Next. So we have a database of projects. We encourage everyone to go to our website and look at this Getting to Zero Buildings database is where we get the information about the projects that are happening nationally. And we encourage everyone to please add your projects to this so that we build an even deeper set of data that we can draw from. Next. So the data, again, back in January looked like this, that we have projects across 36 states in every climate zone and representing a whole variety of building types, and certain places like California with the most number of projects. Next. That we see that there's a trend of mostly new construction, but almost a quarter of projects are major renovations that are getting to Z&E. Next. We see this as a very important trend, and knowing that existing buildings are capable of achieving net zero is important because we have such a large group of existing buildings. So that you think about the data or the goals in California of getting new construction to net zero, but getting half of the existing buildings to net zero by 2030, we have a lot of work to do with 320 billion square feet of buildings in the U.S. And I think this number is actually larger than that because this data is about 10 years old. Okay, next slide. Also an important trend that we're seeing is that there's a trend towards net zero buildings happening in the private sector, and I think that we're going to see this become a growing trend, and seeing this as a differentiator for private development, that there's a new set of economics, the financing these projects and the value of these projects to private developers. But again, the vast majority are are public sector projects. Next. And we see certainly the education sector is playing a big role in this, and this makes sense from many perspectives. Basically how we use taxpayer dollars, the opportunity to provide education, and knowing that this is just a great opportunity to enhance learning environments. So we're seeing a lot of education projects, but also you see the second tier here is office projects and multifamily. And so there's a good range of building types that are achieving or attempting net zero. Next. And we're also seeing looking beyond the building, and I think what we're going to see as a growing trend is not looking at one building on its site, but really looking more at districts and communities. And so we're seeing this trend, and especially with campuses, so both higher education campuses and potentially corporate campuses or institutional campuses, and then the military. So I was recently at a workshop where a member of the military has talked about their 152 bases and that they want to take them all to net zero in the future. Next. An important finding, and I think this is something that you could really take home with you, is that these projects that we're seeing, the data and the energy performance data from these projects, that there is an important factor, which is that they are all ultra-low energy buildings. So they, whereas the national average for CBEX for commercial buildings is an energy use intensity of 93, that these buildings have a range of 0 to 40, with the average energy use intensity being 21. And so, so it's really important to think about energy efficiency first before applying renewable energy. Next. So we're seeing examples, again, across the country, across different sectors. In this case, DPR Construction has been renovating buildings for offices, and in this case, the San Diego office has achieved both LEED NC Platinum, the ILFI Zero Energy Building Certification, and has been verified to achieve zero net energy. Next. And so we track these projects looking at the building's energy use intensity, how much renewable production they have, and then what is their net effect, and in this case a net positive building in terms of its energy performance. And we're also tracking what energy efficiency measures they're deploying on these projects. Next. Also examples like Richardsville Elementary School in Kentucky, and we're seeing policy changes in states like Kentucky and really driving these net zero projects, and actually documenting that these projects can happen at a low square foot cost, and some schools coming in at the cost of an average school being built that's not net zero. So there's some real leadership happening there in the school sector in Kentucky. Next. And again, looking at technologies, and we can talk more about these just in a little bit, but for instance, ground source heat pumps, dedicated outside air systems, of course, daylighting controls, and then energy monitoring. Next. And so a couple of things to take away in terms of best practices, and we're seeing, and we'll hear more about Bullett, but starting with a design budget or a solar budget for your design. So saying what is the capability of our site to generate energy through, in this case, solar photovoltaics, and that becomes the kind of limiting factor on what your building's energy use could be. In this case, the energy use intensity of 16 for Bullett Center. And so that's one principle, starting with a solar budget. Next. Energy modeling plays a really important role, and what we see is with this type of project, there's much more rapid iteration of energy modeling, so energy modeling early and often, and working to drive down energy use in each end use, and in this case, rather than just focusing on the high intensity end uses, really focusing on all end uses and finding how to drive them down and really optimize. And so the case of this project, the Packard building, looking at really focusing on envelope improvements to eliminate perimeter heating systems and save cost, all determined through the energy modeling studies. Next. And then the other thing coming from these projects is learning that once you drive the energy use down significantly on these projects, then a significant amount of the energy that is used in the building has to do with occupants and operations and plug loads. And so there's a renewed focus on not just looking at design factors, but also operations and occupant factors in design. And so NBI has developed a plug load management guide, and this is something that can be leveraged to try and focus in on how you reduce plug loads in these ultra low energy buildings. Next. So the overall trends, just to recap, again, a wide variety of regions across the country and all climate zones. There's demonstrated examples of these projects, many types of buildings and sizes, so it's not just small buildings, it's not just one particular building type. And that we can do this in both existing buildings and renovations, and we see the private sector increasingly embracing this and taking it to scale in districts and communities, and that we really see the education sector as the one where we're seeing the best demonstrations of this. Next. And so we think there's definitely an approach to this that's really important. One is to set that energy goal early, right? So if you're going to go for net zero, setting that goal early, building a project team with qualified professionals that are sharing that goal and actually know that that's part of the charge of their work, and that should be embedded in RFPs and in contracts. Focusing on passive solutions first, those are the lowest cost ways to reduce energy, and so there's great examples of that across the portfolio of buildings that we've seen. Focusing on envelope and glazing and efficiency of the envelope. We're seeing actually a lot of use of passive house principles, if not certification. And then, of course, lighting and daylighting and advancing those, and HVAC controls. This idea of separating the ventilation from space conditioning saves a lot of energy. So just providing dedicated outside air, and then thinking about more hydronic and radiant systems for heating and cooling. And then, again, focusing on occupants and operators and providing good training and education and engagement throughout the process. Next. So, and here, again, the list of potential strategies. These, of course, should not be applied to all projects, but should be evaluated for any project you're working on. Ground source heat pumps, dedicated outside air, demand-controlled ventilation, focus on envelope and orientation, obviously solar control, keeping out unwanted solar heat gain and glare, providing good access to daylighting and good daylighting controls and energy management systems. The engagement of occupants through real-time energy monitoring data is really helpful to have them then use that for actionable changes to their behavior. And then use of radiant heating and cooling. We see a lot of projects using chilled beams, the plug load reductions, and then energy recovery systems as well. Next. So there's growing evidence that net zero buildings can be developed for either a small premium or at the same cost as other projects, and so in this recent NREL study, it says there's mounting evidence that zero energy can, in many cases, be achieved within typical construction budgets. Next. Okay, and then what's on the horizon? Let's just go to the next slide. Well, I guess we'll save that for discussion. I'm sorry. So that's really the Q&A, and so I'll hand it back to you, Paul. Thanks very much.
Great. Thank you very much, Ralph. A couple of questions come up. One is we've seen so much reduction in energy, especially gasoline prices and oil prices recently, and always one of the driving forces for energy reduction of energy consumption is the cost of it. Do you anticipate that having any kind of significant impact on this kind of drive for zero net energy? Are you getting any feedback on that?
Well, I think, first of all, petroleum doesn't really play in our, in our building energy sector very much. It's, mainly used in residential and usually in the kind of the north of the country. So it doesn't play into, the typical commercial buildings are using either natural gas or electricity, and the electricity is not generally using, diesel fuel, or except for islands like the Hawaiian Islands. So, so I think that generally we're not seeing a corresponding reduction in electricity or natural gas prices. And natural gas is a fairly volatile commodity, and so there's fluctuations in gas prices, and electricity prices, are again not pegged to diesel or gasoline prices. So, I think your overall question is a good one. How much does the price of energy impact the potential of net zero buildings? I think it does, but we are seeing these projects happening in places with relatively low energy costs, like Seattle or the Northwest. But then we're seeing a lot more adoption where there's high energy prices. The example would be Hawaii, where electricity can be 35 or more cents a kilowatt hour. So energy prices do factor into the economics of making net zero possible, and obvious thing also is the cost of photovoltaics has been going down and continues to go down. So it's helping to bring more parity around renewables.
And the other question we have is kind of tangentially related to this, and I want to get it because our two case studies are about new construction, but there's huge opportunities on the existing building side. And you talked about that a little bit. Can you maybe just talk what the full potential is on the existing side, and what the biggest kind of obstacle to having success there is? Because it seems that the biggest obstacle is just it's difficult to retrofit an existing building for zero net energy.
Yeah, I mean, I think to put it simply, there's a few factors. One is, are you located in a place with good solar access? How tall is your building? Because if you're going to try and do renewables on site, there's kind of right now a limiting factor where you can't have a building that's maybe more than 3 or 4 stories. Bullett is kind of a unique example because it's new construction that they were able to get up to 6 stories. So how tall is the building? How much solar access does it have? And then the question is what ability do you have to improve the envelope? And so there's a great project in Sunnyvale, California, 435 Indio, which basically they wrapped the building in 6 inches of foam insulation, and they got a great thermal envelope. So how much can you influence the performance of the envelope in that existing building? Is it historic? Are there limiting factors there? Because these buildings are, first and foremost, mostly are focusing on envelope improvements to start with, and then highly efficient HVAC systems. Great. But I think what we need to do is look at those examples that are out there and say, okay, how are they doing it? And so we're getting more and more examples in our case study database.
Great. Well, thanks very much, Ralph. I really appreciate it. What great information. And just a reminder, there was a lot of fabulous information in there, and you will get an email with a link to the slides that you can download them after the presentation here. So our next presenter is Greg Mella. Greg was thinking green before much of our society thought about sustainability or even heard of USGBC's LEED system. He brings an in-depth knowledge of environmentally intelligent building materials and practices to every project, and he uses a whole building systems-oriented approach that examines how to integrate architecture with the mechanical, the electrical, plumbing systems to maximize shared benefit. Greg designed the Chesapeake Bay Foundation's Bullett Center, which was the world's first LEED Platinum building, and he's going to talk today about the Bullett Center, which is just debuted a month ago, I believe, Greg, and I'm going to try and give control of the mouse to you, and we'll see if that works. If not, we'll
all right.
Strategy.
Let's see. Yeah, I think I have control of the mouse.
So just click the button. There you go.
Excellent. Well, thanks, Paul. You mentioned I was the project architect for the Bullett Center for the Chesapeake Bay Foundation. It was a great once-in-a-life opportunity, and then I had a second once-in-a-lifetime opportunity to design the Bullett Center, again for the Chesapeake Bay Foundation. And the client wanted to do the same thing that they did for the Bullett Center, which was to create the greenest building possible. But 15 years later, I think what it meant to design the greenest building possible was a lot more than it was in 1998. So we were pursuing the Living Building Challenge as well as full net zero energy for the project. And just as a little bit of an overview, there we go. The site is on the Chesapeake Bay Foundation in Virginia Beach, Virginia. So ASHRAE climate zone 3A, hot, humid climate, challenging, a cooling-driven climate, lots of humidity, making some of the things that make net zero energy difficult. On the flip side, unlike the Bullett Center, we had a pretty much of a blank canvas of a site, a very low, flat site on the coast, great propensity for wind power, no demands requiring us to build a dense building. We could build a one-story building and have lots of area for renewable systems for the project. And the program is ultimately an education center, partly an office building for 25 employees, 15 of which are for the Chesapeake Bay Foundation, 10 of which are for partner organizations. So there are tenants in this building who are not the owner. That brings some challenges to designing a net zero energy building. But beyond the office component, the building is a bit of a community center and a meeting conferencing center. So there are large meeting rooms with high assembly occupants, as well as varying occupants throughout the day. So some days there may be only 20 people in the building, other days there may be 250 people in the building. So we begin this process of designing a net zero energy in a very typical way that we pursue design in general. We looking at energy flows, we want to understand how a building like this in this climate with this program consumes energy. And you can see right away that equipment loads, plug loads, lighting are really the major drivers of the energy use of this building. And even though we're in a hot, humid climate, given that it is a low occupancy building, heating played a big role as well. So we begin with understanding that. At the flip side, we look at what all the things can we get for free from the site. Solar availability of wind, water table, microclimates. And we observed that we really had a unique opportunity to harness wind for power. It's one of those rare sites that you have the wind speeds and the consistency of wind throughout the year to justify the cost of renewable wind turbines. And just like Ralph said, we begin by looking at orientation and the fenestration of the building, validating initial design moves using energy modeling. Performance modeling really gets integrated into the entire design process as a major component of the way we approach the design. And we knew we wanted a building that was mostly east-west orientation to more easily control solar heat gain. And we also knew that orienting the building slightly to the east has the benefit of letting in a little bit of morning sun to preheat the building, especially in the winter months. And we were using simulation to optimize the ideal geometry for the building. And another big lesson learned from having worked on the Mella Center is that it's very possible to overglaze a building. Obviously, the thermal conductivity of glass is a fraction of what a well-insulated wall would be. At the same time, you can let in a lot of unwanted heat gain from overglazing. So we really approached the design of the project to glaze the building to provide adequate daylighting, not to over-daylight the building, and really not to let in a lot of solar heat gain. And again, modeling, even at a very conceptual level, modeling was a critical aspect to optimizing those kinds of decisions. At the same time, envelope was a big priority, and I learned a lot here. I was so familiar with lower thermal performance, low R values for walls, especially thinking it was a hot, humid climate. Wasn't really thinking that envelope, super high insulated envelope would be critical, but it really, through energy modeling, determined that it was. And we used envelope optimization tools that plotted the energy use of the building at various R values for walls and roofs, and found the point where you were getting a lot of bang for your buck, but before you got diminishing returns, and wound up with R values that were very high, or at least higher than what I expected we'd find. Wall assemblies of an R35, roof assemblies of an R50. Really had a significant impact on the building's overall energy use. And the same is true for glazing. We modeled super top-of-the-line double glazing systems and found that really there were significant benefits, and the triple glazing made a lot of sense here. We wound up with a window product that has an overall R value that's close to an R7. And that resulted, just that decision alone, reduce the energy use of the building by 6%. And another valuable lesson we learned is that even in an externally driven climate program, that really exterior sun shading is really critical, and that the problem with letting in passive solar heating in the winter, especially in Virginia Beach, is you'll have one day where it's 70 degrees outside, and the next day it'll be 25 degrees outside. People from the area know what I'm talking about. So the problem with passive solar design is it indiscriminately lets sunlight in to heat the building in the winter. Excuse me. We found with super high R value envelope that really we were able to completely minimize the heating needs of the building, thus taking the burden off the fenestration of the building to provide passive heating. And really, we were placing windows for daylighting purposes. So the porch that you see that runs the entire south facade of the building is there not only to shade the building from summer sun, but really even to shade the building from winter sun, really relying on internal heat gains to provide the passive heating for the building. Natural ventilation becomes a critical passive cooling strategy. There are only a few tricks in the architect's arsenal to reduce our dependence on cooling, natural ventilation being the critical one. And again, as I mentioned, the site really had phenomenal wind speeds. It had a bidirectional wind, so we had to come up with a design that was flexible enough to accept breezes coming from either the northeast or the southwest. Fairly consistent wind direction, but bidirectional. So you'll see that both the north and the south facades have inlet windows and outlet windows. And excuse me, the building is open now, and we are seeing that the natural ventilation system really works, and that the owner needs to be very involved with knowing which windows to open and when and at what portions of the day. Some of it is automated, some of it is just controls tell you that the climate's suitable for natural ventilation, and people get up and open their windows. We're finding that we can reduce the need for mechanical cooling for as much as about 10% of the year through predictive modeling, and we anticipate that the client will probably exceed that as they operate the building. And like everything else I've talked about, we really used a lot of simulation to optimize the design of windows, in this case for daylighting. We came up with a design, and then we slowly modeled it to see how daylight was entering the building, and then made very minor tweaks to various elements in the building, introducing vertical fins, extending overhangs, adjusting the visible light transmittance of the glass, so that we're resulting with a building that had optimized daylight entering the building and minimized any glare or unwanted heat gain. And the result is what you see here, a false color diagram of the office spaces. And ideally you'd want somewhere between a 30 and 50-foot candle illumination level in these areas. And at the same time, you don't want to overglaze so that you have too much illumination. And you'll see from this diagram that you have a very nice, even, soft daylight level. And we're finding, and this has been proven true so far, that even on a cloudy day, there really is no need for artificial lighting. The only time lights will be on in the building are when the office is occupied at like 5:30 during the winter and the sun is set. But on most other days, there'll be no artificial lights on inside the building. And what artificial lighting we do have, by integrating it with the furniture in the building, you can really optimize energy as well. So that you're providing lights really only at the work surfaces and the places you need the light, and you're not overlighting corridors and other circulation spaces. We did find, as much as we used LEDs throughout the building, that when it came to pendant linear lighting, that fluorescent lamps were more efficient. So there are some fluorescent lamps in the building. It's not all LEDs. And obviously task lighting is a critical way so that you can reduce your ambient lighting levels and only provide light where you need it when people are there. So these are all the conservation measures that get the design down to that super ultra low energy building that Ralph was talking about. We're looking at a target EUI for this building of around 16 kBT per square foot per year. And that, therefore, we sized our renewable energy systems just to meet that far reduced energy load. And we also wanted to create a diversity of renewables to kind of hedge our bets. So we used a combination of photovoltaics and wind to produce the energy use that the building does, that remains in the building. Great. So we predicted at the very onset of design that we were going to shoot for an EUI of around 19 kBT per square foot per year. We needed to come up with a target right away because we needed to size renewable energy systems. And our strategy was that we'd provide 10% more renewables than what we thought the building would consume to kind of guarantee that we'll get to the net zero target if there are variations in climate or how the owner uses the building. And we modeled the building along the way. Our last energy model for the building resulted in an EUI of 16 kV2 per square foot per year. And so we think we're going to be actually producing about 25% more power on site than the building will consume, hopefully. Again, Paul just mentioned that the building has only opened about a month ago, so it's too soon to say how successful we've been, but so far so good. Okay, come on, slide. Huh. It stopped advancing on me.
I think I messed you up there because I moved it. So I'll forward it for you. Sorry about that.
Yeah, I only have 2 more slides or so that's fine. You can go to the next one. So interesting that we did both photovoltaics and wind turbines, in that we also have a cost evaluation of both technologies for this specific project. With the photovoltaics, we wound up with a relatively small array. It's just under a 40 kilowatt array. We found that using the 16% efficient panels was most cost effective, even though you can get a 20% efficient panel on the market. There were more competitive bids at the slightly lower efficiency for the panels. And I think the other important thing for net zero energy buildings is to build in extra capacity for the future. We want this building to be net zero energy not only for its first year under the Living Building Challenge, but forever. And if the project grows to be from a 5-day-a-week facility to a 7-day-a-week facility, we wanted to be able to provide more roof area for future PV panels. And then a very simple economic analysis, we looked at the cost that we paid for the photovoltaic panels and assumed a 25-year service life for those PV panels, and divided the cost, and it comes up to roughly 20 cents per kilowatt hour, which is higher than the rate the foundation pays for electricity, but not higher than the rate in certain parts of the country that Ralph alluded to in his that last question. And go to the next slide, Paul. We also included 2 10 kW wind turbines, and again, it's rare that I'll be able to work as an architect on projects where wind turbines are economically viable and make a lot of sense. But we did have the wind speeds for this project, and they're an important consideration during design because you need to be aware of turbulence and making sure that the turbines are high enough so that they are optimized in terms of their production. That said, putting a 70-foot tall turbine with a kinetic router on a site that's effectively sand does have a lot of cost implications in terms of foundations. The foundations for the wind turbines really drove the costs of them. So they're coming in at roughly 38 cents per kilowatt hours for this project. Now that said, on soils with better stability, that cost would come down significantly. And I should also say that we didn't have a wind anemometer on this site, so we had to get wind speed data from the local airport. I've had a very close eye on the production of the wind turbines now that the building is opened, and I think the actual production is going to exceed what we predicted during design. So I think some of those costs in reality will be a little bit lower. But they didn't make as much sense as photovoltaic panels for this project, but Foundation thought they were an important technology in the region and wanted to include them in the project. Next slide. And this is the exciting world that we're in right now. The building has opened. We're starting to get energy data from the building dashboard, and we're looking at month by month, and even in some cases day by day, how the building is consuming energy and how the building is producing renewable energy. And this shows how we're getting to net zero. Most months we're actually selling power to the grid, with the exception of January, where we have a large heating load, and July when wind speeds really dipped down. But the remaining of the months we're predicting that will be net positive, and overall over the course of a year will be a net positive building. And obviously metering the building and monitoring the energy use of the building is a big component of a net zero energy building. So I hope to come back in a year and tell you how we did, but so far so good. So with that concludes my presentation.
Great. Thank you very much, Greg. Hey, we did have a question about, you mentioned and referred to several times the building dashboards and how you are monitoring energy. Can you maybe dig into a little bit about what you've put in place that allows you to do that so specifically?
Well, I'll do my best. It's a little bit technical for an architect, but ultimately we do have a building management system for the building, and we knew that we wanted to get as detailed energy data from the dashboard during the years of operation. So we planned the electrical panels and the metering so that we can get not only overall energy use on a day-to-day basis, but have that distributed down to what portion is going to lighting, which is going to heating and cooling. And then even because we have tenants in this building, what portion of energy is not only going to equipment in general, but basically to the individual plug on a plug-by-plug basis, because there's an energy budget that everyone has, and in order to get to that net zero energy building, you need to make sure people are meeting that budget. And basically, it's all a series of control points tied into the building management system, which is programmed to produce feed data to the dashboard, as well as produce reports that we're using to verify the energy production of the building.
Great. Thank you very much, Greg. What a great project. It's lovely. Appreciate your presentation. The Bullett Center provided a very different set of challenges than the Brock Center. And talking about that today is Brian Court. Brian's significant and award-winning body of work includes challenging design opportunities in single and multifamily residential, urban infill, higher education, and in waterfront arenas. He received the 2013 AIA Seattle Young Architect Award. He's highly sought after to share his knowledge with the design and sustainable business-minded community throughout the U.S. and abroad. He also enjoys sharing a love of architecture with young folk through mentorship and engagement with design students at the university level. Perhaps most notably, Brian led the design of the Bullett Center, which is one of the most energy-efficient buildings in the world, targeting living building certification and the topic of Brian's case study today. Brian, I'm going to keep my hand off the mouse and try and give control of this thing to you.
Okay, thanks, Paul.
And can you speak up a little bit, please?
Sure. Yeah, I guess there's going to be a lot of similar threads to this talk, to what Greg was talking about and Ralph as well. But I think it really starts to underscore the real challenges with the living building challenge and net zero energy. I guess the first thing to point out with this project is just a little bit about the client. The Bullett Center was built for the Bullett Foundation, which is an environmentally focused foundation based in Seattle. And their mission with the project was really to see if they could fundamentally change the perception that exists, and I guess the reality that a building has a negative, adverse relationship to its environment. So it's really a kind of a moonshot project. Can we build a building that doesn't take from its environment, but one that's mutually reinforcing and gives back? So the Living Building Challenge was adopted as the metric to really guide the project. And let me see if I can get in a little bit to that. Okay, so just a little bit more about the building. It's a 6-story project, an office building in Seattle. You can see the lower 2 floors of the building on a sloped site are built lot line to lot line. It's about a 100-foot square-ish site. And then you'll notice the upper floors, the 4 floors above that, step back about 15 feet on either side, which was a move that was really generated by daylighting analysis, which you'll see through this presentation was really one of the big drivers of the form of the building and how we ended up where we are. You'll notice in this image as well, there's a big staircase that's climbing up the side of the building. That's one of the required fire stairs in the building, but the move here was to pull it to the exterior. One, to help reduce reliance on the elevator in the building. This was an idea to, one, to save energy, but then 2, it really evolved into a better way to experience the building, and something for us that evolved into a nice architectural element. You can see people moving up and down in the staircase, and then we get eyes out on the street. So it's contributing to a safer, better sense of community, I think, for the whole neighborhood as well. Dennis Hayes is the head of the Bullett Foundation, and Dennis was one of the co-founders of Earth Day 40 years ago, so his entire life and career has been really dedicated to this. Dennis's office is in this building up on the 6th floor, and he's been taking this there 2, 3, 4 times a day since he moved in, and Dennis will tell you quickly that he's lost 20 pounds and his belt tightens quite a bit more than it used to. So there's a real health benefit to this as well. What started out as an energy goal took on a sense of community, and then really took on the health of the occupants as well. The building skin, really, as Greg pointed out, a huge amount of effort goes into the optimization of the envelope of the building and the skin. This image gives you a sense of the exterior solar controls. These are really Venetian blinds that go on the outside of the building. That primary goal is to knock down the heat gain. So if we can block the solar gains before they get through the glass, the building's going to perform much better through those hotter times of the season. The metal skins, the Living Building Challenge is looking at toxins and trying to eliminate toxins in buildings. So we thought as much as possible to minimize finishes on materials. So the metal skin has a zinc aluminum coating and then just a clear coat on top of that, so no paint. There's an aluminum window system, curtain wall system, and then aluminum blinds as well. And then an image that we've seen already, but there you get a sense of the blinds deployed and general massing of the building. Coming back to Greg's point about starting out on a net zero energy building, what's the big issue? And for us, it was taking the CBEX database office building in Seattle, which has this operating EUI of 92. And then with this tight urban site, our first challenge was to figure out how much energy could we generate on site. So we looked at the roof and the south-facing facades of the building and just did some quick calcs to figure out how much energy we could generate, which gave us this figure of 230,000 kilowatt hours a year. So we really had to then bring the building efficiency down so that we could match that, if not beat that. So you can see it's this stepping process. The existing buildings are operating at an EUI of 92. The current code in Seattle, very progressive, gets you down to an office building at about 52. We looked at the kind of the current state of the art out there. LEED Platinum buildings with all the energy credits are getting an EUI of about 32. And this project, given what we could generate, about 16 EUI, represented trimming that energy budget by over 80%. So it's looking at really kind of the state of the art as far as efficiency in buildings and examples that we could find globally. This is a matrix that sort of outlines the key strategies and how we worked all the systems to meet the Living Building Challenge into a tight urban site. And I think one thing that's worth pointing out too was early on in the project, the Bullett Foundation asked us to design a building that could last for centuries. The most sustainable buildings out there are buildings that last, buildings that aren't replaced every 30 or 40 years as sort of the financing models are suggesting. To do that, we looked at historic buildings, which buildings have stood the test of time, and we see a lot of heavy timber. The Northwest, heavy timber is a great locally sourced material, so we looked at that for the frame, the foundations, concrete, and then the skin of the building, probably where most of the wear and tear over the life of a building is going to occur in that thermal envelope. So we wanted a skin that could be removed or replaced if necessary, say after 50, 70 years. There's technologies on the building, those exterior blinds, the solar panels, those have a much shorter lifespan, and that's that last layer that would be applied. So we put the building together in a way that we made it easy to maintain over the long term and give the structure of the building its best chance to survive for centuries. So it was about layering and thinking about how the building is going to be maintained as we designed it. There were quite a bit of issues to work through, again, but materials used very deliberately in this project. We had concrete and steel and wood, and we tried to think hard about how we could optimize the potential for each one of those materials. So concrete was necessary as we're coming out of the earth. Steel was necessary to counteract the seismic forces that we need to design to on the West Coast, and for helping some of these timber-to-timber connections where we're really trying to minimize the drift and compression or movement of a wood structure. Steel really helped us out there. And then you'll notice in this image a concrete topping slab at every floor gave us a great way to deliver heating and cooling through hydronics, and then also gave the building some mass, thermal mass that helps us through those shoulder seasons. And then a couple of images inside the building give you a sense of how that timber frame feels, the concrete floors. And then, as Greg pointed out, the real focus on the envelope and trying to minimize loads, minimize energy losses through the course of the year is by far the best way to get to net zero. It's going to be the most economical. The renewable energy generation is quite expensive, but the more energy we can save, the better for the project. So in Seattle, it's a fairly moderate climate. We actually ended up with a wall that's only about R25, so it's just marginally above minimum code requirements. But again, with the moderate West Coast climate, we just weren't getting much bang for the buck as far as adding more insulation to the walls and roofs of the building. Where we did achieve great gains was this kind of orange coating that you can see on the Dens glass. That's a fluid-applied weatherproof barrier that cut our infiltration down about 50%, which that was one of the areas of the building we saw the most gain in the building, was just cutting down on the infiltration. And again, it's fairly standard R values on the walls and the roofs. The windows were another area that we saw significant gains, and that was, again, going with a triple glazed, thermally broken aluminum curtain wall. The water systems that are important to the living building challenge, Seattle, with adequate rainfall, so just pulling the water off the roof of the building and then storing that in a cistern in the basement, a 50,000-gallon cistern, provides enough storage to get us through, say, a 3-4 month drought if needed. So that's collected in the basement of the building. We can then treat the water on site. And the big idea here is not to use chlorine, which is a toxic ingredient. So living buildings are providing water on site, treatment and collection. And then we're treating waste on site as well. So the gray water in the building needs to be treated. There's a green roof in one of the earlier photos. That's a constructed wetland that treats our gray water. We then infiltrate it back into the earth. Waste is all handled on site. We have a composting system in the basement that collects all 6 stories of the building, so we can treat waste on site and then compost that and return it to the soils near the site. This is the water treatment system in the basement. Those blue cylinders are ceramic filters. The tall stainless steel cylinder is a UV light treatment system. So it's, again, these are off-the-shelf systems, not too much rocket science. We like to say that everything in this building had been done before, just not all together at once. Another view illustrating the gray water treatment and then infiltration where those occur. Net zero energy, it was vital to deal with daylighting and natural ventilation in this building. Tight urban site. We're not really opening windows during the day, but night ventilation is critical. So as occupants go home for the night and temperatures drop, the windows automatically open and cool down those concrete slabs. Daylighting drove the design. From the earliest iterations of the project, we were cutting plans and sections through the massing diagram, in this case using a software called Ecotech, to study how daylight was working in the building and how we could adjust massing, and then ultimately through the design of the windows and wall fenestration on the project, constantly coming back to these performance metrics. This was a quick diagram illustrating the typical floor-to-floor with the base zoning height, which was about 11'6", pilot program in place that's designed to help incentivize developers pursuing living building certification. So in this case, they'll give you an extra 10 feet of building height if you can show that it's helping you reduce lighting loads and improve daylighting. Some sketches, just constant studying of structure, for instance, and how we can mitigate the depth of a heavy timber system, and that was orienting the beams perpendicular to the facade so that we could get the window systems all the way up to the deck, which helps us pretty significantly getting daylight into the building. So I guess my point here is a living building trying to hit net zero energy. There's a constant iterative integrated design process where you're working very closely with structural engineers, mechanical engineers, a very intense integrated design process to get the efficiencies that you need targeting net zero energy. This is just a bunch of slides here really illustrating the sort of the depth and breadth of daylighting analysis that the team went through. In this case, the top floor of the building, where we had a real lack of daylighting because of that huge roof overhang. But then we were able to use these daylighting tools to just surgically cut holes in the roof and add skylights without losing too much power, power generation from the photovoltaic panels, but to get as much daylight in there as possible. A couple sketches showing how the skylights get up to the roof. Radiance renderings on the interior spaces, again, to understand glare, and again, how those skylights feel. And then a few views of that sixth floor space with one of those skylight monitors above. And the views back to the skyline of Seattle. The energy PV system on the project, these are off-the-shelf SunPower panels. Because of the tight urban site and the need to go 6 stories, we had to go with the best panels that money could buy. So these are the 20% efficiency panels on the roof. And then views from below. And then I want to wrap up with just a quick take on how the building's actually been performing. We've been finished construction in April of 2013, so we've got 18, almost 2 years of data now. And what's shown here is the predicted energy production of that roof array. So in January it's very low, but in the summer in Seattle we get quite a bit of, really the lion's share of the power generation. Our loads in the building are fairly constant through the year. And then the actual data, the yellow line here, that's the actual energy produced through the first 2 years. So we're quite close to the predicted power production. The big delta for us has been the energy used inside the building, where we're less than half through the first summer. And then as occupancy of the building filled up, we're about 80% occupied at this point. We were about 50% occupied at this point. So our loads have come up, but we're still doing quite a bit better than anticipated. And our mechanical engineers, PAE, have created these graphs showing how the building would perform at various levels of occupancy to really try to gauge how much better the building is doing than anticipated. And we credit this to occupants in the building. Actually, there's quite a bit of spirit in the building to try to use less power, to try to beat these targets, something that I think we underestimated significantly. We've actually seen between separate tenants on different floors of the building almost a competition to see who can use the least amount of power. And the leasing structure in the building that tenants have signed leases with the Bullett Foundation has incentivized them to use less energy. So there are a couple factors that are contributing to the building performing significantly better than anticipated. So as Greg pointed out, this living building is producing more power than it's using through the first course of the year, and we anticipate that that will continue to be the case over the long run for the project. So one last slide here, giving one more view of the building at night. And I think with that, I'll turn it back over to you, Paul.
Brian, thank you very much. What a great performance by this building, and it's interesting to see. So it's been a little bit over a year now that it's been in place and occupied?
It's been about 20 months now. So
20 months
in
now.
April, it'll be 2 years in operation.
And so one of the questions is, and maybe it goes back to even the question for Greg with the dashboards, is do the tenants are this great spirit that they have to reduce their energy consumption. Do they have a method of knowing individually, tenant by tenant, how they're performing, and being able to? Is there a feedback monitor that they can access to say, hey, you guys did great this month, not so great last month?
They do, and I didn't include that slide in this deck. But if you go to the Bullett Center website, bullettcenter.org, you can click on there's a button called Dashboard, and it'll pull up a real-time display of energy use within the building. That's accessible to all tenants in the building as well, and it breaks down energy use by floor and by tenant, and it will show you real-time power production. So every day, how much water we've collected, how much solar energy has been generated. All the vital stats of the building are available to the general public and the occupants.
So the other question I have is about kind of about this partnership that goes on, and it's a partnership that's actually kind of vast in all of these things. And any one of you guys want to weigh in on this, that would be great. But what brought it to mind was your comment about Seattle has these rules about if you add so much more daylight into a building, you can increase the overall height. So Seattle as a city needs to be a partner in the success of this building. You also have the designers, the tenants, the building owners, and all these folks. How do you manage in that environment where you have such a strong focus on Living Building Challenge or Zero Net Energy, all of those partners together to achieve the single outcome? It must have been a ton of discussion and work and focus and advocacy.
I can provide a quick answer to that, and then I'll let Ralph and Greg chime in. With this project, at the outset, when the project was just on paper, there were over 24 regulations in place that would prohibit the building from being built. So we were illegal in 24 different ways, and I think part of the Bullett Foundation's vision for this project was what can they do to make these projects more achievable for other project teams. So they really built into their mission, really taking on the city, taking on regulatory barriers, whether they were city, county, state. It's even gone all the way up to the national level with the Department of Health, and Greg can probably speak to this too with the water issue. You can't provide drinking water. There are all sorts of liability issues, composting toilets in a commercial building, so many different barriers that they're keeping people from doing the right thing, essentially, from an environmental perspective.
Greg, weigh in on that, because it does seem like there is just a ton of stuff, and especially in reusing wastewater, that prevents us from doing the right, as Brian says, doing the right thing.
Well, right. I mean, it's the Clean Water Act is driving the water that's provided in commercial buildings. We did get approval to drink rain on the Brock Center, but the only way we can do that is if we committed to become a public waterworks and design a system that complies with waterwork regulations and have a waterworks operator on staff validating that the water is safe to drink every day. So it's a bit of a burden, a challenge for us to find something that's scaled down so that it's not on a community scale, but appropriate for 10,000 square foot building, and partner with the Office of Drinking Water to come up with a monitoring approach that makes sense for a project at this scale. We hope that it'll be a first type of project and a precedent for future projects, and various public health jurisdictions will realize that it is possible to do safely. But it's challenging. I mean, certainly there's a need to make sure that these buildings are safe and the water that is being provided is safe. You certainly want a pandemic to arise if a bird poops on the roof and someone gets sick. So it's balancing safety and resource conservation. And I think the only way to really do that is to have precedents out there that that kind of prove these things work at a commercial scale. And in time, hopefully, there'll be more products, and the roadblocks will be far and few between.
Ralph, is that kind of, for lack of a better phrase, bureaucratic workaround, having to register a site as a water treatment area? Something you see regularly?
Yeah, and you know, often, especially with these living building challenge projects, for instance, if you have a wastewater treatment system, you need to then have a sanitary system engineer or someone who you're hiring to do that work. And so, you know, I think what this is a signal of, and what Dennis Hayes and others have been doing, is basically using these projects as a way to really question current policies, codes, regulations, and try and create a pathway for living building projects, for you know, net zero projects, and these sustainability features. I think the point is not every project team or owner can go through that, and so some of these leading projects are trying to clear these hurdles and really, you know, make the change so that the broader market can then use those changes in policy without having to have the burden of going through that. But what I would say is you know, there is an opportunity with every project to kind of tackle what you think your special kind of unique interest is. So, you know, some organizations want to focus on water, some want to focus on waste, some on energy. And so that's always an opportunity to say which area are we going to focus on, and where can we make some headway. And in what are, you know, I think very good regulatory policies that maybe just are in need of a fresh look.
And that just kind of speaks to the idea that overall these performance measurements that we saw from the Bullett Center, and then we're going to begin seeing a lot more of from the Brock Center, are just essential for, on the advocacy side, to kind of get things changed. Mm-hmm. Yeah, I guess. So, wanted to thank Firestone Building Products very much for sponsoring this webinar and their help in the industry from education and support. Also, thanks to all of our panelists, Ralph DiNola, Greg Mella, and Brian Court. You guys are fabulous. Thank you so much, and I look forward to working with you again in the future. To our attendees, you'll get a survey after you sign off. Please take a moment to fill that out so we can improve what we're doing here. We need our feedback loops also. And you'll receive an email also to get more information about downloading the deck and qualifying for the CEUs. Thank you all very much, and look forward to having you on our next webinar. Thank you.
Thanks, Paul.